We can use the following equation to help apply the transformations. So if we put all of the transformations together, A value is the vertical stretch, B is your horizontal stretch by a factor of 1 over B, your horizontal shift and your vertical shift. This is what it would look like in one equation. So let's graph a few transformations with radicals. Sketch each of the following and state the domain and range. So this would be a vertical stretch by a factor of 3. Here you're going to have the reflection. Now because it's in front of the x value, it's going to multiply negative x's by 1, so it's going to reflect the y-axis. And then this is going to be shifted right 1. So just like before, we need to apply the stretches and reflections first. So I'm going to get a table of values. So when I'm choosing my x values, I'm going to write down a table of values with what the graph would be without transformations. I'm going to choose perfect squares so I have nice numbers to work with here because you're not going to have a calculator. So we square root those and we're simply going to get 0 through 4. So the table is nice and easy to work with. Then I'm going to use mapping notation to apply these stretches and reflections. So if we have a vertical stretch by a factor of 3, we're going to have 3y, and we're going to multiply the x by negative. So we're going to have negative x, 3y. Now you could put right 1 and actually go plus 1 on the x value, but I like to just count with the transformations afterwards. So we're just going to change all of these signs to negative, and we're going to multiply all of these by 3. Okay, and then we have to remember that we're going to move it right 1 after that. Okay, so I'm going to plot this. I'm just going to plot this in pencil, so this isn't going to stand out as my final answer. Hopefully you can see it okay. I'll try and still do it dark enough here. So we're going to have 0, 0. Because it's stretched vertically, you're going to notice the shape going this way more, and with that reflection, of course, it's going to go this way too. So negative 1 and 3 we're going to plot, negative 4 and 6, negative 9 and 9, and negative 16 and 12 is off the grid. I don't need to plot that. That's okay. So I'm just going to lightly draw this curve in here. And I'm going to label it since I'm leaving it in here just so that we can study with it. You can always erase it after if you don't want it there. And then I'm going to just simply take this and move it all right once. I'm going to use pen as my final answer just so you can see that a little better. But I take each point and I move it right one. I find that easier just to visualize moving right one. It helps me really visualize those transformations rather than subtracting one in there. Sometimes I find we get a lot of arithmetic errors that way. And there's my final answer of y equals 3 square root of negative x minus 1. Now this question says state the domain and range as well. So the domain, when we look at this, would be x is less than 1, where x reals. And then the range, when we look at the graph, y is greater than 0. Now, with the range, you always have to visualize. Again, there was no vertical shift. I do have to consider. So reflection over the y-axis doesn't change the range. The range would be changed if there was a reflection, though, in the x-axis. The other thing I want to point out is the domain would be the same as the restriction. So if I didn't have to graph this and I wanted to know the domain, I could find the restriction algebraically. So I'm just kind of going to show you that because this one's a little bit unique with the negative sign. So if you have what's underneath the radical, so we call it the radicand, you set that greater than or equal to 0 because you can't square root a negative number, so you have to have a positive radicand. So I would then multiply negative sign through the brackets. I'd move 1 to the other side, and then I would divide off the negative 1. And when I divide by a negative with a inequality, that's when the sign flips. So that's where we're going to get that restriction from in the domain.